Detection and countering surface and underwater diversion and terrorist threats has long history, but still there are technological gaps in currently used and newly developed systems. Ports, harbours and critical infrastructure protection is one of the main business fields of R&D Marine Technology Centre, CTM. As early as in years 2000-2003, CTM developed and implemented multi-sensory harbour protection system in Polish naval base in Gdynia. That surveillance system, named Krill, aimed not only at detection of typical underwater threats, such as armed divers, but also at detection and tracking of small underwater vessels that operated near the entrance to the base. System consisted of stationary set of sensors, sonar, IR and TV cameras, magnetic sensors, installed on breakwater and in the harbour entrance, as well as mobile sensors on helicopters and sea vessels. Local command centre gathers all the data from surveillance system, and after data fusion and analysis, decision about use of counteraction means is made. Significant impact, influence on further development of detection and deterrent systems against sea terrorist threats had conclusions of several reports prepared by NIAG with CTM contribution. SG-86 Harbour Protection, SG-110 Maritime Force Protection Effects in the Above Water Environment, SG-126 Intelligent Sensors for Underwater Mines and IED Identification. Important influence on the D&D development had also results of technology demonstrators test carried out within NATO's and EU's workshops, as well as experience gathered during EU's 7FP programs. Those works were the base for formulation of our proposals for 2011-2014 Defence Against Terrorism Programme of Work projects. Ports and harbours protection systems are developed on two capability levels: minimum capability and full capability. The first one consists of radar, IR and TV cameras. Sonar is aided by data from VTS and AIS, while the second one can include both magnetic and acoustic barriers, and sometimes passive hydroacoustic antenna arrays and sensors carried by ASVs and AUVs. Detection of threats from armed divers performed only by acoustic means is relatively difficult and leads to intolerable level of false alarms. This problem is clearly visible, especially in water areas with high acoustic noise typical of ports and harbours. Aiming at elimination the technological gap in underwater threat detection systems, CTM in 2011 joined Defence Against Terrorism Programme of Work and carried out several mutually complementary projects. The development of the Multi-Sensor Surveillance System Technology Demonstrator for Underwater Asymmetric Threats Detection and Classification. Portable Magnetic Barrier for Underwater Force Protection. Portable Underwater Detection and Deterrent System against armed divers. Detection system is based on acoustic modules, or DDS, that create acoustic barrier and online of magnetic field sensors that form magnetic barrier. Portable magnetic barrier can be used both for port and harbour protection, as well as for force protection as complementary system that strengthens detection and classification capability of underwater terrorist threats. Sensors used in detection systems are characterized by high sensitivity, reliability and ease of deployment and recovery. Multi-sensor underwater threat detection system was initially tested in CTM's laboratories and later in PN Naval Base in Gdynia. For the trials purposes following operational scenario has been used. Group of terrorist divers has been transported on board container ship in standard 20-foot container into an area of Baltic Container Terminal, BCT. Under cover of night, basing on compass course, group tries to cross underwater the distance between BCT and NATO wharf and to attach carried limpet mine to dock ship. Then group tries to return to container that will be loaded onto container ship and will leave port of Gdynia. Portable magneto-acoustic barrier deployment in port's 8th basin between BCT and NATO's wharf, connected to local command center on board ORP Arctovsky, continuously monitors underwater situation and generates light and acoustic signals upon object detection and then alarm signals. Operator console screen shows divers, yellow arc, moving towards group of ships moored in the harbour with the intent to plant limpet mines on the hulls. After detection of the divers by acoustic barrier, target detected, signal with distance to the target is shown. Magnetic line crossing signal is generated after crossing of magnetic barrier by the target. Alert signal is shown on the screen. In normal circumstances, in that stage counteraction with effectors is undertaken. For presentation purposes, operational scenario was simplified. Diver miners group deployed from motorboat in 8th basin, and they will start to advance underwater towards docked ORP Arctovsky ship to deploy limpet mines. After detection of the group by the detection system, hydroacoustic low-power signal will be emitted. After receiving that signal, divers will emerge to the surface. Field tests and real situation showed that protection of ports and harbours or force protection of groups of ships moored inside the harbour or on anchorage is possible using multi-sensor underwater threat detection systems. System operates with relatively low false alarm rate, even in harsh environmental conditions in water areas characterised by high levels of acoustic noise and electromagnetic interferences. Following project realised within Defence Against Terrorism programme of work in years 2013 to 2014 ended with development and built of technology demonstrator of integrated detection and deterrent system against armed divers. System consists of above-mentioned sensors, threat detection, and newly developed, tested and integrated in this project non-lethal effectors, airgun, semi-lethal and lethal effectors, pyrotechnic effectors with various charges. In typical ports and harbours protection scenarios, acoustic systems continuously monitor water area and are aided by magnetic barrier, ensuring effective detection of underwater threats. After detection of divers, AUV, UUV by DDS, acoustic systems, and confirmation of that detection by magnetic barrier, appropriate effector closest to the target can be activated automatically or manually. Pressure pulse generated by air guns, usually order of magnitude smaller than the one generated by small explosive charges. Due to that, effective radius of operation of air gun is much smaller. Air gun can be lowered from small boat not farther than about 10 to 15 meters from detected threat diver. Pyrotechnic effectors can be deployed on the sea bottom and activated manually or automatically, both using wires or wireless by acoustic signal generated by detection system. By use of effectors with various charges, initially smaller ones can be activated that act as non-lethal deterrent means. If it is not sufficient, larger lethal charges can be activated. Sea trials of technology demonstrator of integrated detection and deterrent systems against armed divers and live presentation for NNAG were performed according to the following operational scenarios. Group of diver miners simulating attack on ships moored inside Maritime Coast Guard basin is deployed from motorboat on waterway to Gdansk harbour at distance of about 100 meters from detection systems installed in basin. Group of divers will try to approach underwater the ships moored inside the basin. After detection of divers by acoustic barrier, target detected signal will appear on the operator's console, which will change into alert signal after detection and confirmation of presence of divers by magnetic barrier. Detection system automatically chooses appropriate effector for activation, which is signalled by blinking effector sign at the situation plan of the basin. Operator has to decide about activation, man in the loop. During presentations, explosive charges were replaced by smoke charges. Colour smoke appeared at the position of diver detection. Sea trials and live presentation for NNAG have confirmed effectiveness of the system. It can be used both as stationary D&D system for protection of ports and harbours and as portable system for force protection. Technology demonstrators developed and tested within Defence Against Terrorism Programme of Work projects are important contribution to the further development of harbour and force protection system in NATO.